So, very good morning to all the students. So first, let us see the syllabus copy before we start the new unit. And I request any one person or the CR to update the HOD, the syllabus coverage. Okay, how many units we have done as per the JNT syllabus. If you see the power electronics, the first unit we have done. Okay, and only one topic you are supposed to study of your own, that is material I have provided, which is nothing but thyristor ratings only. Protection means SC snubber circuit. Thyristor ratings, if you buy one SCR, the company people will give you the voltage rating, current rating and power rating. So that it is completely theory one. So that is updated in the material also. Thyristor ratings is the topic you have to study from the first unit. Okay, just the theory. And next, if you see, next we have done. Second unit is all about the converters. Okay, RL load, RLE load. The animation what you have seen, you can draw the circuit diagram. You can go through the material. Material will be the explanation what we have discussed. It will be easy when compared with the material. And if you see the converters, DC to DC choppers, okay. So first topic is step down chopper and its waveform equation. And next one is boost chopper. And the last one is step up down chopper. So all the topics are similar here. 3 derivations we have seen. And then the problems also we have taken. But beyond this, we have taken DC Jones chopper, DC Morgan's chopper also. They might ask in the external examination. And they can also ask you classify the choppers or class A, class B, class C, class D, and class E. We have taken pretest. So 3 units we have done. Okay, if any topic, any student think that we have missed out, you can ask me directly. You can unmute and you can ask me, no problem. Okay, later on you can message also. Today's topic will be very much important. So after completion of this syllabus also, we will start working with the MATLAB projects. That means if you join any company, what projects will be given to the engineer? Those type of projects through MATLAB only we are going to work in the industry. So your super seniors also, I think the Anusha Kulkarni, the very first batch student of our college, she is working for the MATLAB company. Okay, in Hyderabad also it is present. So be perfect with the inverters. The most important product of electrical engineers is the inverter. So it should be DC to AC. It is printed raw inverters. So what is the basic word when you say the inverter? People say DC to AC or DC current to AC current. Electronic people with the help of transistor also we can convert DC current to AC current. Okay, but that simple inverter operates only for 12 volts and 5 volts. Electronic circuits which contains the transistor can also act as inverter. You might have studied the NOT gate inverter operation. But what we produce as an electrical engineers, we deliver power inverters. So actual name is nothing but the power inverters. So power inverters convert fixed DC power to variable AC power. So fixed DC power to variable AC power. So inverter is a power electronic circuit which converts fixed DC power to variable AC power with the help of power electronic devices. I hope you people have got the explanation. Inverter is a power electronic circuit which converts fixed DC power to variable AC power. Okay, and that variable AC power can be obtained at different frequencies also. So inverter can generate at different frequency. Right. So we'll look into that one. So now I'm going to start the new unit which you are taking. Now you can see the very first introduction. You can see the animation of the inverter. So now if you, where we use now, if this is the most We can say you can survive with this topic, inverter, and I can assure you that all the students will be. See, please log in very fast because if I'm just taking students are logging right now. Again, I have to change this slide. The animation will not work if anybody is logging on right now. Okay. So if you see, the most important thing, everybody knows that from the battery we get the DC current, we have to generate the AC. All our components are AC here. And so here if you see, in your house, let us say you are using the solar panels. Okay. And we convert DC to AC, and that AC power which is generated by you at your house premises, it can be transferred back to the grid and government people will pay money for you. So this is what you people have to remember. So in your house, if you are placing the solar panels, if the solar panels is connected to the inverter circuit, then you are generating the power. If you are generating the maximum power beyond the requirement of your house, that power can be transferred to the grid, and then government of electricity department will give the money for you. For 1 unit, certain rate will be fixed. Okay, so this is what is going to be implemented now and in the future also. So we use the inverters here when the supply is the solar panel also. Let us go back to this slide here. One second. Right. So that is the first basic. The second slide, as an engineer, you must understand. You can answer, in our house we are getting AC. Okay, I can connect directly any fan AC load, or else I can even connect the induction motor to the AC supply. So why we are having this inverter? Now remember all of you, here you see, I want to control the speed of AC motor, induction motor, let us say in the industry. Many industries we use the induction motor, let us say textile industry, a cement industry, we are going for the induction motor. So wherever I want to use the induction motor speed will be controlled by varying the frequency. This is the best method. How to control the speed of the induction motor? Induction motor speed can be controlled by the change in the frequency. So now, for every industry, input will be AC with 50 hertz, but you cannot directly apply this 50 hertz to this particular induction motor. Therefore, what we do in the industry is we convert AC to DC, rectifier circuit, what we have studied converters, and then we have to convert DC to AC, and then we obtain variable frequency to run the motor at different speeds. If the frequency is less, the motor rotates with lower speed. If the frequency is high, the motor rotates with maximum speed. So if you go to any industry, example, the movie theaters, the multiplex theaters, all the multiplex theaters, they contain the inverter. Electrical engineers have been placed in the multiplex in theaters. Okay, so what they do, they get the electricity, they convert the AC to DC, and once again through the solar panels also they convert, they generate the DC. The DC is converted into the AC by the inverter, but at different frequencies. That is the specialty of power electronic circuit. So power electronics is a branch of science which deals with the control and conversion of electric power. Inverter is a power electronic circuit which converts fixed DC power. When we say the power, DC current and DC voltage, fixed DC power to variable AC power at different frequencies. This point is important. Okay, at different frequencies. We cannot say directly DC to AC. Fixed DC power to variable AC power at different frequencies. You can see the frequency is changing here of the input AC circuit, right? So let us move to the next slide. Right. So I just will discuss this one, this particular slide, all of you. So first topic, what we take in a inverters unit is Inverter means, remember all of you, H bridge inverter. The complete name is H because the circuit will be in the form of H shape. Okay, H bridge inverter. So inverter, we are supposed to generate from DC to pure AC. Okay, so this is the example I am showing. So first we are having certain circuit where we are using the SCRs. You can see here BJT or any component. Input is DC supply. Input is DC. If the DC supply is not constant, we must place a capacitor in parallel with the DC supply. Capacitor provides dash voltage, constant voltage. Okay. So in any power electronic circuit, if the supply in parallel with the supply voltage, you are having the DC capacitor. So capacitor provides the constant voltage, even if the input supply is not constant. So I'm using certain power electronic components, and which signal is generated? I'm asking one simple question. This square waveform which you are seeing, is it AC or DC? Anyone tell me? The square waveform which you are seeing on the screen is AC or DC? Current or voltage, whatever it will be. Anyone tell me? Unmute and tell me, please. So using this circuit, we are generating this signal. Okay. So this is AC or DC? Any student?
AC.
Very good, AC. Because it is having the positive off cycle as well as the negative off cycle. The signal is having the positive half and negative half. Whether it is a triangular shape or rectangular shape, so if it is approaching the equal amounts of positive off and negative off, it is called the AC. But we require pure AC. Pure AC means what? It is pure sine wave. Practically, now remember this point, no company is generating the pure sine wave with the help of inverter. So we say the inverters are there. What is the complete name of the inverter? As per the syllabus I am moving, H bridge inverter. H bridge contains certain SCRs. Okay, you can see here. When these SCRs are turned on and off, we generate the AC signal. But that AC signal will be in the shape of square wave. Okay. Now what we do, we use the concept. Now you can see the second animation. Pulse width modulation is the most important topic which we study in this unit. So where we are having the inverter circuit contains number of switches. Now this square waveform which cannot be given to bulb. If it is given to the bulb, bulb will never grow. If it is given to any induction motor will never understand this AC signal, square waveform. So they understand pure sine wave. But what is the disadvantage of the electrical engineer still there? No engineer is developing the pure sine wave which we get from the AC supply. That is the problem. So what type of signal we generate? So this signal which is generated, it will be passed through the pulse width modulation circuit and concept. It will undergo this particular process. Then we obtain this type of signal. Anyone tell me what is the pink color waveform you are able to see? Anyone, can you tell me what is the name of this signal? I'm giving the option DC, AC, or none of this. Pink color waveform name. Anyone tell me? Answer. It is DC, AC, or none of this.
AC.
Option is what? C. What is the answer? None of. No. Right. Okay. Right. It is called modified sine wave. You can see it is having certain curves here. It is not purely positive off cycle and negative off cycle. You can observe this one. So this is the so what is the name of this signal? Modified sine wave. Remember all of you. Inverters generate which inverters? Bridge inverters. Okay, the circuit what we are going to take first as per the syllabus is bridge inverters. Bridge inverters contains certain SCRs or MOSFETs or any type of power electronic element. They first generate this square waveform. Square waveform is again modified to modified sine wave. Modified sine wave is 95% equal to pure sine wave, but it is not equal to the pure sine wave. So today, if you are studying this power electronic subject, you must understand, you design the new circuits and see that you are generating the pure sine wave, then everybody will buy your inverter. Okay, I will show you one video in our lab also. We have practically developed one inverter circuit which is turning on one bulb as well as small fan. Okay, right. I will make every student to develop their own inverter circuit. This is a promise using the breadboard and certain components. In the breadboard, if you are connecting, we will develop the new circuit, okay, which generates the AC supply. So what type of signal the inverter generates? It is a modified sine wave. So how this modified sine wave is created, that is also one topic. But as it is introduction, I want to show you the bridge inverter is the inverter used everywhere. H bridge inverter, that circuit will study. But that H bridge inverter, first it generates the square waveform, and then which is also the AC, and then it is modified to modified sine wave. But in practice, no company is going to show their circuit in the Google images or else in the internet. Even if you search the internet, different inverter circuits, those inverter circuits are only for educational purpose. That means if I connect this circuit here directly in the lab, it will never generate this modified sine wave. Only for educational purpose, these circuits are given. The real circuit, every company is their own, they are having the legal rights. Okay. Now, examples of inverter companies, anyone tell me? Microtech inverter, you might have studied. Okay. You might have seen the ad also. Now, nowadays, the inverters, we are coming up with the smart inverters, which can be operated with the remote control also, smartphone also. So how to develop the smart inverters, we'll study that is beyond the topic. So very first class, H-bridge inverters are used everywhere. Our first topic is also bridge inverter. Bridge inverters generates dash waveform. Anyone tell me? AC waveform or DC waveform or modified sine wave? What they generate? Bridge inverters generate modified sine wave. Modified sine wave is 95% equal to the pure sine wave. It is having the behavior of the pure sine wave. So now this modified sine wave can be given to the bulb, it can be given to the motor, it can be applied to any type of load, and the load will work satisfactorily. Now, if you want to do the research work, you can improve the modified sine wave and can make the modified sine wave to pure sine wave. Number of engineers are doing the PhD work. They are working 24/7 to develop the new inverter circuits with low cost, with fast operation, which generate the pure sine wave. But everyone are ending up with the modified sine wave. I hope it is clear now. Okay. So H-bridge inverters generate modified sine wave. Modified sine wave behavior is 95% equal to the pure sine wave. Therefore, this type of modified sine wave inverters can be used for all applications. I hope this point is clear. This is the point you have to write everywhere when you are explaining the inverters. So another name for bridge inverters is modified sine wave inverters. If you go for an interview, they will ask you, can you generate the circuit for pure sine wave? So answer, we will see at the end of our unit. Okay. So this unit should be taken with a full discussion. Okay. Now, I'm taking you to the simple H-bridge circuit. First topic, basic H-bridge inverter. You can see one motor we are having. Our aim is to rotate the motor. Let us say here we are taking the AC motor. Okay. What is this H-bridge? It is in the shape of H. I'm using 4 switches, 4 SCRs you can say. Input is pure DC solar panel or battery. So first, what is my logic here? Bridge. So two S1 and S2 are S4 are 2 SCRs. 2 SCRs will be off, on, closed, and other 2 will be open. So the motor rotates in one direction, and I want to rotate the motor in another direction. So what I'm going to do? I'm going to open S1 and S4, and these 2 are closed. So in that, then the motor rotates in opposite direction. So now one question I'm asking: which current is flowing through the motor now, to this motor, AC current or DC current? How to confirm that AC current is flowing through the motor? So remember, all of you, anyone tell me what is another name for AC current? AC current, another name? Another name for AC current is bidirectional current. Another name for DC current is unidirectional current. So yes, Inverter is a power electronic circuit which converts unidirectional current to bidirectional current. So how to confirm that bidirectional current is flowing through the load? So if the current flowing through the load is in one direction and then in opposite direction, then which current is flowing through the load? Bidirectional current. So I repeat the statement. How to confirm that AC current is flowing through this motor? So with the help of switches S1 and S4, current flows in one direction. When S2 and S3 are closed, current flows in opposite direction. In this animation, only one direction we are able to show. Okay, you can see only both are closed here. So if the current flowing through the load flows in one direction and then in opposite direction, then that type of current is called AC current or bidirectional current. This definition is important. If the current flowing through the load is in one direction and then in opposite direction after a certain period of time, then that current is called bidirectional or AC current. So inverters convert unidirectional current to bidirectional current. Okay. So now you see here, I come back to this one. So now you can see what is the first topic here. Single phase H bridge inverter with resistor load. Resistor load means bulb. You can draw the same diagram. You can use the MOSFET here or a SCR you can use. Okay, first I am showing one simple circuit. Now I am asking, this is a circuit. Okay, all students, please unmute yourself and be ready because inverter is your life, entire power electronic subject. Okay, if you are having the agriculture land, government is going to give you 80% of the money to start one solar power plant and to generate the electricity. All of you are understanding or not this one? So many students can start their own company and they can run their agriculture motors, boring motors also. Okay, water pumps also using the solar inverter. So remember, solar inverter will be your future. So basic inverter circuit contains 4 SCRs or 4 MOSFETs and it is in the shape of the H and load is connected in this manner. So now I want to pass which current to the load? Anyone tell me? I want to pass AC current or DC current? All the loads, 90% of loads are AC. So I want to pass the AC current, but the input is what? DC. So how to explain this operation here? Case 1. Case 1 is what here? When MOSFET 1 and MOSFET 2 are turned on with the help of firing pulse. So what will happen? Direction of the current start from? Yes, anyone tell me? Direction of the current start from VDC plus to MOSFET 1, MOSFET 1 to load, and from load to MOSFET 2, and from MOSFET 2 to the VDC minus. You can ask one question, sir, can we use the SCR in the inverter? Anyone tell me, can I use the SCR in inverter? No, answer is no, because SCR, to turn off the SCR, we require complicated circuits, but MOSFETs can be easily turned off. Okay. So maximum inverters will never have the SCR, they go with the MOSFET only. That's why here also MOSFET, source drain gate. Examination point of view, you can draw the SCR also. This is the one more animation. So what is the case 1? So when the supply is on, okay, we are giving firing pulse to MOSFET 1 and MOSFET 2. Therefore, direction of the current starts from VDC plus. You can see in the same way examination you have to show. Power electronic circuit, no theory explanation. Circuit current direction is our language. So VDC plus to MOSFET 1, MOSFET 1 to load, and from load to MOSFET 2, MOSFET 2 to the VDC minus. This is the direction of the current you have supposed to write. Okay, current is flowing in this direction. You can see here plus and minus, voltage developing across the load. Okay, now we move. Now what is the case 2? After a certain period of time, with the help of forced commutation circuits, we turn off MOSFET 1 and MOSFET 2. Already you have studied forced commutation circuits in the first unit. Okay, how to turn off these SCRs. So with the help of forced commutation circuit, we turn off MOSFET 1 and MOSFET 2, and we turn on MOSFET 3 and MOSFET 4. Then the direction of the current gets reversed. So what is the case B? Case B says case 2 or case B? MOSFET 1 and 2 are off, open, and MOSFET 3 and 4 are on. So now the direction of the current starts from positive terminal VDC plus to MOSFET 3, MOSFET 3 to the load, and from load to MOSFET 4, MOSFET 4 to the VDC minus. Now all of you tell me what you have observed from the two circuits. current flowing through the load is in same direction? Anyone tell me? Or in opposite direction? In both the circuits, you see current is flowing in this direction here. Okay, you can say this is A and B. Current is flowing from A to B. And what is the case 2? Current is flowing from B to A. Understood? Here, I hope all of you have observed this one. Please confirm by us, anyone student? Yes or no? This circuit, because this is your life here, inverter. So current flowing through the load is it is AC or DC now? All the students. Come on, all of you, be activate for this circuit. Current flowing through the load is AC or DC. If you understand this only, then we can design any new circuit. Yes, this is the H-bridge inverter. Current flowing through the load is AC current or DC current now? It is 100% AC. How we can confirm? Because first, in case 1, current is flowing through the load from A to B, and in case 2, current is flowing from B to A. Therefore, this is 100% AC current, bidirectional current. So now we just move on to the next topic. Okay, single phase full bridge inverter with inductive load we are going to take. Okay, full bridge inverter with inductive load. Right, you can see the now the slide. Okay, so with resistor load we'll discuss. Now all of you be ready for this explanation. Be perfect. So we are just moving to the next slide. Right. Ready all of you? Anyone confirm with unmute? Okay, have you understood the resistor load or not? The simple direction. Very good, very good. Right. So now the most toughest topic we are taking in the inverters. Single phase full bridge inverter with inductive load or RL load. Anybody tell me what is the example of inductive load? Motor we can take, DC motor or AC motor. As we are discussing the inverters, our motor will be induction motor only. Okay. So single phase full bridge inverter with RL load. Resistor load, no diodes will be present. Remember, all of you, any circuit you see, resistor load, diodes, freely wheeling diodes will not be present for dash load, resistor load. Freely wheeling diodes will be present only for the inductive load. Okay. Now choppers also we have seen similar circuits. Okay. But here inverters means all the students, you can draw the exact diagram in the examination. Inverter means the SCRs will be shown in this manner, and converters it will be placed reverse. So H bridge, it is in the form of H shape. How many SCRs it is having? 4 SCRs. And how many diodes? Diodes are connected in anti-parallel. T1 and D1 are connected in anti-parallel. That is, anode is connected to cathode, and here also cathode is connected to anode. So what is our aim? We have to send which current to the load? We have to send the AC current or bidirectional current. Anyone tell me what will happen in the case 1? Any student? See, inductive load means the windings will be have the inductance. Okay, we have to treat this one as the inductive load. Come on, I am going to start the case 1. Who will tell? This is the circuit. You can ask, sir, I want to design the inverter with 3 SCRs and 3 diodes. Yes, you can try. Nobody has designed till now. You only thing is nothing but you are supposed to send bidirectional current. That means current should flow in one direction and then current should flow in opposite direction. Then your job is done. So now you see all of you. Case 1, what will happen? Anyone tell me? Case 1, first I am giving firing pulse to T1 and T2. Okay. You can ask one question, sir, what is the use of these diodes? Whenever inductive load is present, the same statement you are going to write. Because of the presence of the inductive load and the inductor, after a certain period of time, inductor releases the stored energy or inductor de-energizes. The de-energizing current will flow through the diodes, any 2 diodes. Okay, and it comes back to the inductor. So whenever inductor releases the stored energy, the stored energy will be traveling through the diodes and it will come back to the inductor. That's why we are supposed to place the inductor. Okay, now come on. So what is case 1? Case 1 is when T1 and T2 are turned on with the firing pulse. Okay, and when the supply is on. When the supply is on, direction of the current starts from which terminal, all of you? 100% from positive terminal only. Okay, The direction of the current starts from positive terminal, current flows through the T1 to the load, and from load to the T2 to the V minus. During this process, if the load is motor accelerates, gains kinetic energy, rotates in forward direction, and the inductor starts to energize. As the current is entering in this direction, this will be plus and this will be minus. Now you can see the representation of the animation here. Okay, you can see supply is on. The direction of current is from V plus to T1 to the load. Okay. The motor accelerates, rotates in forward direction and increases its kinetic energy from the load to T2 and from T2 to the V minus. You can see the animation. So direction of the current you have to show. So what is the second line you are supposed to write? During this process, inductor energizes and stores the energy. Okay, and motor accelerates. That's a common point you are writing. So after certain period of time, in case 1 only, after certain period, case 2 you can keep. Case 2, de-energizing of inductor. De-energy. When inductor de-energizes, the terminals gets reversed. The energy gets reversed. So this will become plus and this will become minus. You can see the animation also. Once again, you have to draw the circuit. So now you can see inductor is de-energizing. So in the animation, it is not mentioned here, plus and minus. So you people, you mention here, once again draw the circuit, you put it here plus and here it is minus. So when say case 2, inductor de-energizing. When inductor de-energizes, the de-energizing current flows from L plus. This will be L plus now. L plus 2, you can see where it will flow D3 and from D3 to the source. So you can ask, sir, how the current flows from inductor to source? Because now when inductor is completely energized, the voltage across inductor is greater than the source voltage. So that's why the current flows from high voltage level to low voltage. So now when inductor de-energizes, the de-energizing current flows from L plus to D3 to source, and from source is DS you can write, from source to D4 and from D4 to the L minus. So I hope you understood this one as we have taken in choppers also. So inductive load. Inductor releases the energy. That energy is passed to the diode D3 to the source to the D4 and D4 to the L minus. Okay, right. So what is the case 3? Anyone tell me? Now current is flowing through the load in one direction. Now you can see. Now I am passing the current in opposite direction. So case 3 is T1 and T2 are turned off and T3 and T4 are turned on with the help of UJT firing pulse. That means case 3 says that turn off with the help of forced commutation circuit, we turn off T1 and T2. Okay. So what's going to happen? So direction of the current starts from V plus, VS plus to T3. Now the T3 is on. You can see in the animation. From T3, the current flows through the load. Load contains inductor. Now you can see the plus sign is indicated here. Okay, because the current is entering this terminal, inductor is energizing. The current flows from Vs plus to T3 to load, and from load to T4, and from T4 to the Vs minus. Okay, so this is the direction of the current. So case 3. Now during this process, inductor energizes in opposite direction. Okay, it stores the energy. You can see the current is entering in opposite direction. Now all students, now remember this point. Since in case 1, current flowing through the inductor is in one direction, and in case 3, the current flowing through the inductor is in opposite direction, the current flowing through the load is 100% AC current or bidirectional current. How can you confirm that bidirectional current is flowing? In case 1, the current flowing through the inductor is in one direction. In case 3, current flowing through the inductor is in opposite direction. Therefore, AC current is flowing through the load. Okay. So bulb, if it is there, it will turn on, but inductor. Now you can see case 3. We are giving firing pulse to T3 and T4. Vs plus to T3 to load, and from load to T4 to Vs minus. During this process, inductor energizes and stores the energy. And the motor, if the load is the motor accelerates and rotates in which direction? Anyone tell me? And rotates in backward direction. Okay, so you can write simple word: motor accelerates and gains kinetic energy. Okay, so so after certain period of time, what will happen to this inductor? Inductor starts to de-energize. Yes, sir. So now you can see the animation. After certain period of time, now case 4, inductor de-energizing once again. So after certain period of time, inductor de-energizes. So initially here it was plus. Yes or no? Because current was entering. I'll show you once again. Here it was plus, you can see. But now inductor is de-energizing. When inductor starts to de-energize, okay, now I think the screen is shared. Wait for the screen. Internet problem, I think. So net connection. So now you can see this the inductor is energizing. So after certain period of time, yes, after certain period of time, inductor starts to de-energize. You can see inductor is energizing. Okay, after certain period of time, inductor starts to de-energize, its potential gets reversed. Okay, plus and minus. So now what's going